Hello everyone, welcome back to the Allen Block Workshop. Today what I want to go over is internal compound stability, or ICS, and how to run this calculation during a retaining wall design in the AB Walls design software. Designers typically have been limited to analyzing a design for internal and external stability and bearing. Internal compound stability compares all the sliding and resisting forces, including the contributions from the geogrid and facing blocks. This comprehensive calculation allows designers to run calculations on difficult sites and configurations to bring a higher level of analysis to the retaining walls design envelope. This also provides an extensive internal analysis, allowing you to see where the weakest area of your design may be with a pressure map visualization tool. So let me share my screen with you. Let's start by defining what internal compound stability is and its role during a retaining wall design. Internal compound stability is an iterative calculation comparing the forward sliding forces against the resistive forces along a circular potential slip surface that passes through the unreinforced retained soil, reinforced soil mass, and the wall facing within the wall design envelope, as defined in the Concrete Masonry and Hardscapes Association Design Manual, Chapter 8, and the Allen Block Engineering Manual, Chapter 6. Thousands of iterations are accomplished in seconds to find the most critical potential slip surfaces. Unlike most segmental retaining wall design softwares, this portion of AB Walls accommodates grid in the slope to provide a more comprehensive design and analysis. This presents a clear distinction between internal compound stability and global slope stability with regards to design possibilities, with internal compound stability providing a design envelope analysis defined as greater of twice the height of the wall or the effective height, plus the length of the grid. The wall designer should review the internal compound stability for each wall on the site. The owner, through a contracted geotechnical engineer, should review the global stability for the entire site, including the soils below the base materials of all walls. Additionally, because internal compound stability considers the geogrids and wall facing as resistive forces, AB Walls helps me ensure I have a coherent gravity mass, as well as checking for localized bulging. This makes it possible to design retaining walls with geogrid and alternate design options like reinforcement placed in the slope above the wall, no-fines concrete, double block, and complex composite structures. To run internal compound stability in AB Walls, I first need a cross-section modeling site conditions. Following guidelines laid out in Allen Block's best practices, I have created a wall and have panel section 3 on our screen with the external stability already calculated. I want to then click Calculate Internal Compound Stability and then click OK on the reminder that internal compound stability is not the same as global stability. Internal compound stability is an iterative calculation, and I can see how many times it ran on the Parameters tab. If I want a visual representation of the results, I can go to the Draw Pressure Map tab and see where those slip arcs are exiting through the face of the wall. When I go back to the cross section, I now have visual indicators showing where the most critical slip arcs are occurring. As I progress through the remaining panel sections of the wall, I may receive a message that more than 50% of the slip arcs are concentrated at the back of the design envelope. Remember that internal compound stability is looking at only the design envelope of the retaining wall, and this message is a warning that there could be a potential global stability issue. As the designer, I would note the occurrence and pass that result along to the person responsible for the overall stability of the site to investigate further. Internal compound stability allows me, as the designer, to have a more complete picture of the forces at play, especially for complicated sites that require solutions outside of a conventional segmental retaining wall. Typically, wall designers have used internal calculations centered on the geogrid layers. But if I have a wall with multiple types of reinforcement, all internal compound stability needs is the total sliding and resistance forces, allowing internal stability to be calculated. This is crucial for complex composite structures, as well as no-fines concrete and gravity walls, as they do not have geogrids. AB Walls makes it simple to run the calculations, But what can I do within AB walls if the results are below the industry minimums? Internal compound stability functions as a ratio of the resisting forces versus the forward sliding forces. So if I want to raise the amount of resistance or decrease the sliding force, I can do this in 4 ways. First, I could bring in a better backfill material with a higher friction angle, decreasing the sliding force experienced by the wall. Second, I could add more layers of grid and tighten the spacing between layers, so the slip arcs have to pass through more grids and distribute the load. Third, increase the geogrid lengths into the retained soil to drive the worst case slip arc deeper into the hillside. The fourth solution is tied to situations when there is a slope above the retaining wall. Slopes above a retaining wall will have a large influence on the stability of the wall. Like the retaining wall, the soil in the slope is being built back up after being disturbed. Adding additional geogrid into the slope following the same length and spacing used in the retaining wall will increase the stability in the same way that lengthening grid layers within the cohesive soil mass do. So why does this all matter? Remember that before internal compound stability, designers were limited to internal and external stability and bearing analysis. Internal compound stability adds value with comprehensive calculations, allowing designers to handle complicated sites where the traditional methods of analysis fall short. With the AB Walls design software, you can save hours of design time running this high-level analysis and be able to modify the design with a few clicks of a mouse. Be sure to calculate internal compound stability on your next project. For additional videos using AB Walls, see allenblock.com. Always better, always Allen Block.